And yeah, so we're in strange times, so maybe this is a welcome escape from the world outside for an hour or two. So yeah, just welcome and thanks for joining. We've got some on tonight. Can everyone see my screen?
Yep.
Okay.
Yes.
So Andrew and Andrie from LSD showing off navigating containers, which is going to be really good. According to the Meetup group's feedback, when asked what everyone wants to see, containers, Kubernetes, managed services, that kind of thing came back as a clear interest. And then we're going to have Q&A sessions after each of the presentations. And then at the end of everything, if you miss a question coming later, we're just going to leave it open for a couple of extra minutes just so you can get some of the questions in. I know I've been advertising the next presentation is only going to be done by Mac, but I found out today that Andrie from our Cape Town team also helped prepare it. Thanks guys for putting in the work presentation for us. They're part of the LSD Cape Town office and really knowledgeable on containers, microservices, Kubernetes, that sort of thing. And yeah, thanks. Enjoy the presentation. Mac, you can take over.
Cool. Thanks, everybody. I guess this is the part of the show where everyone runs quickly and normally would run take a break. So just saying, how's it? In case anyone needs to run, that's okay, because I can't actually see you and I won't notice it, and I'll keep talking. So navigating containers. Can I ask you to just stick up your hand raise your hand if you are currently already using containers? I heard a couple of Docker things earlier, so I'm just going to watch the participants things, just look for hands. I see Timo, a couple other guys, or must I keep it anonymous and just say I can see 1, 2, 3 hands, 4 hands. Oh, that's nice. When you put your hand up, it groups you all together. That's nice. Cool. All right. Cool. And now can I ask everyone else to lower their hands? And if you're not yet using containers, would you stick up your hands for me? Jules, not yet using containers, I'm sure. Okay. Cool. So the reason for that question is not to be obtuse. It's just to talk about kind of containers and where they go and where they fit in. And I just want to make sure we kind of explain for where everyone is kind of with their understanding and experience of containers so far. I'm going to share the screen in a moment, and I'm going to take over from this. Let's see if it'll. Yes, let's do that. Okay, so. And if I go to here, desktop 2, that should be able to do that. Can you guys all see my screen?
Yeah.
Okay, cool. So navigating containers with Andrie, Swart, and Andrew McIver, and it's Andrie and Andrie, Andrew and Andrie. So that's oh no, it's kind of hard to get the reaction. Alrighty, so what is a container? This is a container. I brought some containers along. And the reason we use containers, there's lots of There's lots of technical reasons, but the reason for me works the same way as the reason we do this with our food. We put food in containers, and you don't want to put all your leftovers from your whole supper, your vegetables, your spaghetti, your meat, all together in one container, because then it kind of tends to all leak together. If you want to go to take salmis with you to work, and you also want some healthy salad, then you put those all in together, you end up with lovely soggy bread that kind of smells a bit weird. So we put each component, each piece of food that we want in our own little container. So we do pretty much the same thing with containers as a tech, and we do the same thing. So the benefit of that is if one of our applications smells a little weird, we can throw that one out and have it replaced without having to throw away the rest of the stack. So that's my non-techie explanation on containers. So from a slightly more perspective of it, why does it help? Containers, you hear phrases like infrastructure as code, infrastructure automation, as phrases that come up quite a bit. And that relates to being able to describe in a text file, pretty much, how you want your applications to run, and completely fine-grained, so you know exactly what is there. So that's doable. You know, you can do infrastructure as code using virtual machines. But because the virtual machine has got more parts in it, it becomes more and more complex to rapidly change those pieces out. So I'm going to scoot along to a little graph here on my screen, VMs versus containers. And, oh, there's, maybe that's not the best one. Let's pick kind of, yeah, all right, that's fine. So fundamentally, a VM is nice because we've got a big beefy server and we can split it up into smaller pieces. And if one VM goes down, it shouldn't break the other ones. It also allows us to do stuff like migrate VMs from one place to another so that we can patch our underlying infrastructure. I think everyone's kind of clear on what the benefits of a VM are. What a container does is it takes it one step further, and instead of being, and in this sense, the containers that we speak of here, in the case of like Docker type containers, is that they are application containers rather than server containers. So instead of saying, I need a server to run my applications, you just say, I need to run my application. So the amount of libraries, the amount of abstractions that have, and virtualizations that have to go into place to virtualize a BIOS and an EFI and all kinds of other bits and pieces, and the amount of kernel modules and things you need to support that kind of virtualized infrastructure gets reduced, so that you have one shared kernel, but you still have isolation via some pretty cool tools like C groups and network groups and things like that, to give you a small, easily packaged application. So in this sense, a container is just to make it nice and small and easy to be packaged. I've got a slide there that explains pretty much what it's all about. One of the key bits around this, especially if you're dealing with like things like Node.js, for me, that's where containerization helps a lot. Obviously, it helps in Java and all kinds of other things, but typically, if you got a framework like Node.js, your application might require certain npm plugin, npm modules loaded, and those modules might not work so well with somebody else's Node app that's also running on the same server. So then you've got to figure out exactly and keep track of all these little dependencies and watch out for collisions. So by packaging your application and its dependencies inside of a Docker container, you get to reduce that possibility of crosstalk. And then we kind of jump on across to Kubernetes architecture, which is really great. Not right. So we've got containers, and that's all good and well. But how do we run them? I think some of you guys will have seen, if you're using Docker on your machine, you can say Docker, Docker run, and you start a container. It's beautifully easy, but you have the exact scenario of if it stops, how do we know it's stopped? How do we, if I'm running on one machine, but I've got more servers that I need to run this on, how do I move it across? How do I manage that? And that's what something like Kubernetes is for. Which I will get to in the demo and explain exactly a bit more how that works and how that looks. Kubernetes is an orchestration engine. So in that sense, its role, Kubernetes is to containers what vSphere is to virtual machines. Is that okay? Everyone with me so far?
Yeah, man.
Yep.
Cool. Sorry, it's really weird because I can't see anyone else, and I can only see the screen I'm sharing. So, as I said, Kubernetes is to containers what vSphere is to virtual machines. You can run an ESXi host and start VMs on it. And that's great, they run, but you don't get live migration. You don't get that monitoring the metrics, the status, the liveliness checks and things like that, that you would otherwise with the scheduler, the orchestrator. So Kubernetes handles the orchestration and scheduling of containers to start your containers where they can be started, to check that they're still healthy, and if necessary, kill them if they need to be replaced. It allows you to put limits and guarantees on the resources, the kind of things that you would have expected if you were doing VMs. You want to make sure each VM is guaranteed a certain amount of memory, a certain amount of CPU. So Kubernetes does that for containers. Without Kubernetes, it's pretty difficult to do that. Obviously, it's not the only container orchestration tool out there. However, it's pretty much the winning orchestration engine. So it's the de facto standard. Any questions so far, guys? I'm just going to click stop share so I can see everyone else. Okay.
Can't see any.
Right. Okay. Cool. Then I'm going to go into a demo with Andrie. So we're gonna start with an application that I'm going to show you guys up on the screen now again. This is just a website. It happens to be running on OpenShift. OpenShift is a Kubernetes distribution. Other Kubernetes distributions is AKS for Azure Kubernetes, Azure Container Services, EKS. I see, Billy, I see your question. At what stage should you start considering Kubernetes instead of just a couple of Docker containers? That's a very good question. The short answer is probably the moment you need them to be reliably running. And there's some smaller, lighter weight Kubernetes distros sort of coming up on the scene, stuff like micro Kubernetes, which allows clustering, K3s, which are much lighter and less, not quite as heavyweight, so they're really good for edge use cases, like edge of the network kind of IoT use cases. You know, their requirements are much smaller than a full-blown Kubernetes. However, their API is Kubernetes, so you know the commands and that all work. Yeah, I'm happy to chat about that a bit more.
Sorry if I can jump in there. Billy, another one is depending on also the size of your application and the resources it requires. I mean, like you could easily have a AWS instance that's got a cloud init script or something that runs, that installs Docker and then just loads up your container from a Git repository or something with a load balancer in front of it. And then obviously if the container dies, the load balancer sees it and it trashes the machine and starts it up again. So you can have multiples of those. But as soon as you start getting into like higher resource utilization and you need to implement kind of like observability and monitoring, all the enterprise kind of stuff, you tend to kind of look at container orchestration via Kubernetes or something.
Yeah, that's cool. Yeah, I did see some chats earlier about Helm and Kubernetes and stuff like that. So obviously Helm is a feature of Kubernetes. Kubernetes uses the whole sailing kind of metaphor. So Helm is the steering stuff, and it's used to deploy and manage deployments inside of Kubernetes. So its goal is to help allow you to roll out and upgrade applications, roll out new versions of the applications in a Kubernetes cluster. And in that sense, because Kubernetes, it can handle out the, gracefully, bringing in new versions of the application with zero downtime, which is hopefully what we'll be able to show you in a few moments. So no, Helm's not like Terraform. Terraform is maybe further lower down than that, I would say, not in terms of its usefulness, in terms of what it aims to be like. Where Terraform says make my applications a certain way, Helm says go and put my application in place. But in that sense, I suppose infrastructure as code, they do certainly have some crossover. But the way they work is a little different. Andrie, I don't know if you got any insight there you want to share?
Yeah, no, for sure. I mean, like Terraform, for example, you can have in you can call it code, but you can define in a document that please go out to this cloud provider, create for me these networks with these routers, with these ingress and with these firewall settings, and then spin up this kind of VMs with this operating system, or create this cluster. So you can provision a very complex infrastructure deployment from VMs to application layer and everything with Terraform, where that would be infrastructure as code. The Helm is basically just defining how to deploy an application into Kubernetes.
If I can interject, I would say think Terraform very much like Ansible. We have a script that defines the entire stack that you want to deploy with all the configurations. Helm can probably be more associated with something like a satellite server, where you want to install a package or a small module. Helm will do that for entire Kubernetes microservices-based application onto the Kubernetes cluster. So it knows what to download, how to install it, similar to a satellite deploying a new module on Linux.
Lekker. Yeah, thanks. Share this. Just want to check if that's coming up. Is that sharing again for you guys?
Yep.
Alrighty. So Andrie set up this all the infrastructure for us today and yesterday and the day before that, and he used infrastructure as code. The underlying Kubernetes platform was created, but the applications themselves were deployed from text YAML files. So sort of to prove the concept, the previous demo we did of this, the whole system was entirely trashed, and this was all rebuilt from scratch. That's me using my suspender to limit things. All right, so you can see the website here. It's just a little app to rate fruit smoothies. This is a shameless plug from Azure's Red Hat OpenShift workshop. As I said, I'm looking at OpenShift here, but OpenShift is Kubernetes. So the things we'll show you are true for that. It's just got from our side an easier dashboard to see things like this over what the sort of normal dashboard and interfaces from a Kubernetes perspective go. Once you're using it, it essentially it might not matter so much. It's just nice to be able to get these kind of metrics and things like that out of it. So that's not the focus. Here's our fruit smoothies, and what we want to show you though is that if I scoot to the right place here, builds, storage, compute. There we go. Workloads, pods, deployments, and deployment configs. So what we've got here are pods. So to just come back to containers, when you run a container, or when you have a container, it starts off as a container image, which is akin to an exe file or a jar file or something in Java. It's your package. It just lies there, does nothing until you run it. So when you instantiate, when you do a Docker run, or in the case of Kubernetes, it takes a container and wraps it in what's called a pod, and it launches that container for you. And that's how Kubernetes keeps track of where things are going, what they're running on. So you can see here on the screen, you can see which node this is running on. We can see the namespace it belongs to. So Kubernetes allows you to separate out applications from each other. So you can have 5 copies of the same application that can't talk or interfere with each other. So it makes it great, an easy way to be able to have a lot of automated deployment, a lot of CI, and a lot of continuous deployment type workflows, because it is able to run several copies of something with isolation from each other, it can also give you resilience and reliability. Yes, thanks, George. Agreed. Give you resilience and reliability by being able to run replicas. So yeah, George's point, while it's not running, it's an image. Once it's running, it's a pod, and the pod is typically comprised of one or more containers. So here's our pod. So how Kubernetes knows what to do with a pod is via a deployment. That's an instruction or deployment config in the case of OpenShift, because they're much of a muchness. That's an instruction which looks like this. So you can show it up on a text file. It just, let me see if I make this bigger. Let me know if you can still see that. It's a text file that says what to do. So for example, this says the strategy for this is rolling deployment. In other words, when we want to replace this, we keep the previous pod running until the new one is ready to handle traffic, and then we fade the traffic over to the new pod. There's the image to use. In other words, that's the container image that we're going to launch as a container in the pod. And all of this stuff is text. So and because it's text, obviously, the nice thing about text is it works well with things like Git. So you can put these kind of configurations in Git, and it work with workflows like that, so that you can manage your approvals and audit processes via the normal Git flow of branches, merging, pull requests, to have those things tracked from a very much a developer-like workflow. And you'll probably see that a lot of the Kubernetes tools are a lot of these applications are quite developer focused in terms of it's application focused. So we're trying to bring where developers work in code and having the operational parts of that closer to them as code, so it's clearly to be versioned and visible. Yeah, Jules, like GitOps. So here we've got application, it's defined, it is busy running, you can see it over here, and that's its URL. I just point out over here, I'm going to make a change to this in a moment. So what that looks like is that code that's busy running here comes from a Git repo. It could be on GitLab, GitHub, Bitbucket. At this point, it doesn't really matter. And you can see we forked this off of Microsoft's Rating Web demo. So there's a master branch here, and we've set up some webhooks that when we make a code commit to this, it will make a change to our application. So I'm going to share my whole screen now to hopefully make that a little more clear. So let's go here, get status. I've got a push ready to go, so I'm going to go and push my code.
Up, please.
Yep, cool. There we go. I'm moving, and probably better if I don't make it see-through. So it has now pushed to GitHub, and if I refresh the GitHub page, it should show that I have lost. There we go. Andrew Mac was here. I've committed. So what's going to happen is at the background here, we've got some tasks going on, and just waiting for this thing to, it's run through. There we go. We've got a build running that's kicking off automatically. What it's doing here, it's done a git pull from the Git repo, and the benefit of this piece here is from when we want to run the code, we can get pretty much right back to the code commit that was made by a developer. So if you've got this very far removed process, and it can create a lot of distance, a lot of effort to try and find out what version of my app am I running and how do I know how we got to that version. By having it brought all the way to basically being able to have the actual Git commit itself visible, it's very easy, if there is an issue, to go back to which issue, at which Git commit did this issue get introduced. So this build process busy running, and it's probably finished by now. usefully within this, we can see the logs of what it did. Okay, it's still busy going. I don't want to expand this too much. Let's do that there. So there we go. It's generating its bits and pieces. If you're used to NPM, you're used to seeing all of those kind of messages, the normal NPM stuff. Am I going okay, guys? Doing all right?
Yeah.
Okay, cool. Right, so it says it wants to see some more. As with other Kubernetes tools, you can get these logs pulled down to your machine via kubectl and things like that. Importantly here, successfully pushed the image. The image has been successfully pushed. Now if we go have a look at our pods, which we have running, the workloads pods.
Sorry, maybe I missed it earlier. What Docker registry are you using?
Okay, this is running the this was pushed to the internal registry inside of OpenShift.
That's cool.
But it could have been pushed to Docker Hub or anywhere else, assuming you wanted to.
Sorry for interrupting. So in terms of getting your application onto the platform, there are multiple ways of doing that, either via, building a Docker container from a Docker file, or we have something called source to image builds, where we basically connect to a Git repo, pull in the actual source code, and then the platform figures out, oh, you're running .NET or Java, whatever. Let's pull down appropriate official image for that and inject the code in there and then store it in the local platform registry.
Cool, thanks, Andrie. And this way I'm going to ask you a question. Just checking here, we've done our build, and if I go look at images, it should show builds, image streams. It should show that we are rating web has had a build. That's showing a bit way away. Image count 2 minutes ago, so that's fine. So I'm checking the image, and I'm going to go back to deployment configs and check when we last deployed. So rating web, 1 of 1 pods. And I just want to check something. Just want to check, Andrie, were we going to auto roll this out, or are we manually?
So it's already rolled out. Yeah.
Oh, okay.
So go up to pods, you'll see the time running. It's going to be ratings web 3. And if you refresh, then it should show you the updated.
Okay. Should show me the updated piece of code. Yeah, it does. Sorry, there it is. I saw it was 3 and it was so fast I didn't get by. So there's my tiny little change that went through macros here. So deployment config again. Here we go. So if we go to the pod, which was the running pod. So what I'm going to do is I'm going to work backwards from here now.
Sorry, Mac.
Yeah.
Just one question, probably a bit of a new question, but in those pods, what exactly are you running? Do they have like a built-in web server type thing, or
yeah,
is it a
so
Node.js effort, or?
Yeah, so I'm just going to, if my mouse will behave itself, we'll go across to that GitHub repo. I'm just going to chuck this across into the chat. If you guys want to have a look at it, as you say, it's forked from Microsoft's repo. You'll see under source, it's a Vue.js basically. That's what it is. And so it's basically it's a Node.js type little servlet itself.
There's no web server anywhere. It's just the Node.js built in.
Yeah, just somewhere. Yes, yeah.
So there's 3 components to this. Sorry, Mac.
Go for it. Yeah.
The web front end, which is Vue.js, and then there's an API and also a Mongo database running in the background. So those 3 are put together. Mac, you can maybe explore the whole config environment settings and environment variables and stuff like that.
Cool. Right, I'm just going to go back to the deployment config so you can see the pieces. So there's the ratings API, the ratings web, and they all work together. So if we go across to the build configs, you'll see the Git repo, the Git URLs for those pieces. There we go. So you can see how those work. So this is just again, the point with this example is to show a code commit producing a Docker image compile or Docker image build, and then running in that. In terms of your question around a web server, so the front end onto OpenShift then is handling is effectively a reverse proxy web server, and it handles the load. In theory, and in practice, I guess it's usually the same. If we need to handle more load than what this one container would do, we'd scale out this container rather than trying to put a bigger, sort of a heftier web server inside it. But like Tim said, in terms of his his Elastic stuff, it also depends on what you're trying to do.
So the OpenShift web server that's built in does the actual scaling and finds out what pods are available to scale over.
Yes. Yeah. So whether you're using an Amazon ingress load balancer or whatever, whether it's an ELB or anything else like that, they handle that. It's what's called the ingress or the router. Yeah.
Is there a registry where these things sit, like etcd or something, that it knows where the things are to scale to, or to load balance over?
Sure. Okay. Sure. Yes, it does. It does track that. I'm not. That's a good question. I'm not sure where it stores that information itself, but most likely etcd would be the place to be. In the config of, for example, in the deployment config itself, you've got. Just go where it is here. Let's go check here. No, that's not what I wanted. I wanted the other one. You've got horizontal, something called an HPA, a horizontal pod autoscaler. We don't have one on now, so we can manually scale our pods from 1 to 1 to 3. But horizontal pod autoscaler is one thing, and then obviously in Kubernetes 1.17 and newer, obviously, so in OpenShift 4, there's more metrics that you can use to scale upon. So you can have it it defaults to be CPU, but it could be memory. There's ways of, again, depending on how split up your application is, you can choose, for example, if your database server starts having a lot of hits, to scale up, more of, not necessarily more database nodes, that's a bad example, but you can say, I need more front-end pieces because we're going to be expecting delays, so we need to build up our cache or something like that. So you can put that sort of logic in depending on how you write it. But at its base level, it's horizontal pod auto scaling. Does that help?
Yeah, pretty much. We run PHP, so it's slightly different and it's complicated. So trying to get a handle on these things.
Sure. So I mean, we do some PHP stuff as well. So I guess I don't know if we can kind of bounce on that a bit. I don't know if it's so. What you would likely do, I don't know if you're using separate PHP FPM or you're running it. Okay, so in that case, I guess your choice is to have multiple PHP FPM containers, and and using the ingress to balance across to those. But I mean, if you wanted to, you could run an Nginx container as well and use that effectively to balance onwards. The one thing with containers that maybe I didn't say right from the get-go is because each piece is a separate container with effectively its own networking stack, you don't get to use, don't easily get to use sockets. So when you've got running PHP on one server and you're running Nginx and you want to talk to each other, you can often use the local socket. But if you're going to split these out, then you will call them by their names, their service names, rather than by a shared socket.
Mac, you get that using gRPC and network stack like Istio. Those two together will give you a persistent socket configuration.
Yeah. So Istio and those kind of things have got a lot of cool benefits and things. Obviously, by adding that, you're obviously adding a bit of complexity, which may be very, very well worth and very beneficial, versus kind of the smallest Kubernetes you can get. So, thanks. That's great.
And gRPC. gRPC is the one that actually gives you the persistent socket though. The Istio gives you the load balancing and monitoring across that network stack.
Cool. Thanks. Oh, sorry, that went too privately to George. I meant to be everyone. There we go. Your gRPC. Cool. Just in case anyone wants to go look for that later.
Thanks.
Right. So to work backwards again from our pod, we've got our pods, which you could see here, which we've set the replicas now to 3. So we've got 3 of them. When I hit a web request to the name of my application, so wait for things to go, it goes to one of these. And that's also something that when you're dealing with containers, you have to be aware of is how are you storing the session data, the session information, how are you managing that? Because ideally you want your container to be able to come and go without impacting somebody's user experience. So that's one thing that does definitely affect your architecture versus a very kind of stateful instance and handling session data. So I'm not sure exactly how everyone's current architectures look, but that's something you may need to watch out for. And the other part of that where that comes into play is, as we see oftentimes, guys might have an external load balancer or web application firewall, and then it comes to OpenShift or to their Kubernetes platform, and then gets to the load balancer itself again. So instead of going from a request through one reverse proxy, you've effectively gone through 2 reverse proxies. So it's very easy to lose the originating source data. So to kind of make a session sticky is very difficult because you've separated so many times from the original request. So that's just something around that to watch out for. All right, so our pods are running here. What's called a service is the internal load balancer that handles what gets balanced. So we've got a service here called Rating Web, and this has got a DNS name and it's got its own IP address. So when I browse to this website, I'm getting to the root or the ingress. The traffic goes through to my service, and from there it gets distributed to the actual running pod. So it's at the service point where Kubernetes does all the health checks and makes sure that the pods that it needs to talk to are available, but it doesn't know what those things are themselves. That's on you as a developer or to basically specify how Kubernetes is to check the health of your for the health checks. Here they are. Where they're liveliness and readiness. Anyway, I'm going to scoot across to the YAML to show you here how Kubernetes is supposed to know whether your container is alive or not. Where are we? Have I scrolled past this too fast? This names, resources, API, search generations. I'm looking for health checks. Does this not have health checks? If we don't have health checks, then Kubernetes will just start it and it won't know if it's still running. So let me just check here. Pods environment. Andrie, do we have health checks?
You can start a demo app from the catalog. Okay, no, that's cool. Then it's fun. So if you don't have a health check, which would explain why the pods get ready so quickly. Then obviously Kubernetes assumes I started it and it's good to go. With a health check, it allows it to manage and keep track of if a container is still capable of handling traffic, and of course if a container has reached the point of being ready to handle traffic. Yeah, there's a message to you, Charles. I think the answer to that is yes.
Yes, I will.
Any questions, guys? Any more questions?
Hello? No questions.
I'll take that as a no. Cool. So to work backwards again, we have a pod. That pod we run multiple replicas of, and traffic reaches my pod via the service, and the traffic reaches from outside the platform via an ingress or a router. Each pod contains one or more containers, and the difference between a pod and a container, or a way of seeing it, is that a pod is effectively the smallest unit of containers running. If a container, if it's the pod that dies, or the pod that is considered to be ready, rather than for the whole pod has to be ready in order to handle traffic. It's not a case of we can have a pod that's half ready and half handling traffic. So usually we tend to find pods of just one container, but sometimes you have what is called a sidecar. For example, something to handle authentication, a little authentication proxy, so that you don't have to write the whole authentication method into your application itself, but you can just leverage a little container that's deployed with your main application container each time as a pod. And a pod is hosted on one node. So any containers that form part of the pod will be on the same node as the other containers in the pod. I'm not going to go into like stateful sets and all kinds of things like that, and replica sets and replication controllers, other than to say that, as the name suggests, the controller controls how many replicas. We've got 3 replicas running here, and if we score 2 now, sorry, because I scaled it down, that's all handled by replication controllers. The other part around Kubernetes and containers that is quite important is the handling of storage. So you know, when you're running Docker on one server, you can easily say Docker run -v, and you give it a volume, and it mounts that volume in from the host, which is very convenient. But if you're using something that could run on any one of several hosts, then you need to have it persist data and write data down to a file system or to some piece of storage, then that becomes quite an important question. So the handling of storage in the container space does quite matter, and it's possibly the one that's probably the hardest thing to solve, or the thing that's the most effort to solve at the moment. How do you handle dev staging and prod deployments? From Julian.
A Mac, the
yeah.
uses persistent volumes, and you can see the claim from the actual.
Cool. All right. Thanks, man. So yeah, that's the storage of the thing. And if we were to look inside the container, we'd be able to see the DF to show us the storage. This is using a GPT storage class for this, obviously hosted on Amazon.
Yeah.
Julian, did you have is that purely a question, or do you have some suggestions that you'd like to suggest on that?
No, I was just wondering, because I work a lot with doing a lot of different deployments, especially like staging and user acceptance testing type of stuff. And so I have to build the whole deployment and send that to a team for testing. And I'm just wondering, I'm usually organizing my stuff in a Git directory. So the way you organize your Kubernetes YAML files, when you import your GitLab directory here, how does that actually reflect? So how does it import? Do you need to do it in a specific way, or can I still split it up in a specific? Because I, for example, have like a deployments folder underneath my client, and inside there, I then have all the Kubernetes services and config maps and secrets and stuff that I need for that specific deployment. And
okay. Yeah.
Using Red Hat OpenShift is and another thing is I work with a lot of clients that has like different services on the cluster, and we usually use namespaces and stuff. So how do you actually split and categorize and organize your projects in OpenShift?
Yeah, so the same way in OpenShift as you probably would in Kubernetes, in that you isolate, you separate at namespace level, and there's obviously also no one way of doing this. There's there's no absolute. I don't think there's anybody who's got an absolute answers to what needs to go into one namespace and what can be shared. But my usual kind of rule of thumb is if it is a set of applications or set of microservices that are reasonably closely related or tend to be deployed together or have or that need to be able to access each other with a good amount of freedom, then having those co-located in a namespace. It's not co-location; it's organized, but it's having them in one project or one namespace is helpful. I would think, Julian, that maybe looking at something like Helm might be obviously a learning curve and stuff like that, but it would allow you to effectively go deploy a chart and therefore a version of a chart to a namespace.
I think something that Julian might be missing actually is OpenShift is Kubernetes. OpenShift is just Red Hat's distribution of Kubernetes where built. It's still Kubernetes underneath it with everything in a normal Kubernetes deployment. It's just Red Hat's distribution.
Yes, it's the skin. Yeah.
I can still use my current Kubernetes deployments as is.
Exactly the same. Exactly the same.
Yes. Yeah. Thanks, Julian. What I was trying to suggest was maybe, and again, whether Kubernetes or on EKS or Kubernetes on AKS or Kubernetes on OpenShift, in that sense, either way, that a tool like Helm might help because you can package your application as a chart. So Helm deploy or Helm install at least, and have that targeted a particular namespace to deploy your application in a dev namespace or to deploy your application in a UAT namespace. And the fact that all packages up as an archive, as in the config itself, as a zipped arc or tar.gz, basically, would allow you to keep track of what was deployed or what needs to be deployed. We do some stuff at other places where we use Helm kind of for that as a way of deploying stuff to particular namespaces and saving that as code so that we know what is there, but which is very similar to what you were describing with a deployment folder. I mean, a Helm chart is very similar.
Oh, thanks. I'll definitely check out Helm.
Cheers, Billy. I saw the CI/CD stuff with DevQA and stuff like that. We can definitely do that at some point for another meetup as well. Yeah, sure. Go for it, Andrie.
Yeah, no. So yes, I could hear from the discussion and where it was leading that we probably don't have time for that now, but we could definitely have a look at doing something similar, but then focusing more on like a CI/CD workflow. Some responses for people interested, so that would be cool.
Yeah, and I think if we did that, kind of like we could do it as a sort of more of a deep dive. Thanks, George. A build pipeline.
A platform or a forum where kind of these things can be raised, or ideas of people of what they're interested in seeing.
You guys can vote on it and say.
Yeah. So what we can do is we can use the Meetup group as the platform and add some stuff. Some feedback surveys and maybe some general feedback would be fantastic too, so that we can kind of see what people want to look at.
So George's suggestion or George's thing that he'd like to see is yes, into UAT, cat in a hat, was actually what Andrie did on Thursday and Friday last week, before it all got torn down over the weekend. But this was also part of it as well. So we had several different ones that we would do, but obviously time constraints. We didn't want to kind of overcook this part. is there any questions from an architectural point of view as to what makes up containerization and where it's good for? Maybe like where's it not good for? Anybody else got any questions around that?
Yeah, so I've worked a lot with containers and stuff, but something that I've done that I know is like technically probably wrong, and I don't always know what's like a better alternative, is like I've often had situations where I had to kind of let's say like when I was using ECS with like a PHP application, build images for the containers where the code was kind of baked into the image, and I don't always know if that's a good thing. Like, I mean, like when do you do that, and when do you like have the code like maybe sitting on like a volume, for example? Like when is it a good idea to do that, and when not? Like, yeah.
Yeah, so that probably talks a lot to maybe one of the questions the guys had earlier about using with PHP. Should we ship the app inside the container or mount it as a volume? I think the only thing I can that is probably an easy answer on that is, as far as possible, to externalize your configuration. So if you can run your same application in dev, prod, and QA, but for example, your PHP code makes use of a different DB connection string, for example, then externalizing that and providing that via a secret or something like that, or an environmental variable as a secret into the container would definitely be preferable to than hard coding that part of it. So the config part is that if you can externalize a lot of that, that would be beneficial. The question of whether to put on a persistent volume or inside the container, it probably has to do with the size of, well, not even really, I mean, doesn't really, but bear in mind that there can be a time overhead in attaching a volume to a pod as it starts. So depending on how fast your application needs to scale and respond, if the code is baked into the container, then it's there and it starts up with the container. It's not a separate step to, oh, I want to start, Kubernetes doesn't have to go, I want to start a container, now I have to give it a volume and then it can go from there. And the other part is obviously around the immutability of the data itself. If you've written that application as something that has been approved and signed off, then having that in the container means you know exactly what is there. There's no chance that somebody else has edited that data via some other means. Notwithstanding, obviously, if it has to write data out, then you'd still need a persistent volume for that data. But for the application code itself, putting it inside the container would mean you know that you know that you know that you know what is inside it.
So,
like with that,
also security. From a security point of view, if your code is actually in the container, it becomes immutable. It gets most of the things like OpenShift will actually, once the container, the image is actually created, it'll create a signature of that container. Anytime when you redeploy it, it will check against your original signature, make sure it has not been tampered with. So from a financial point of view, you can show that what's running there is what was built into it through your dev pipelines. It wasn't hacked or anything. So there's also, you make it as small as possible, but put as much as possible in it from a code point of view. But as Mac was saying, put the configurations on the outside. So that simple YAML file will define as how many replicas, what database to connect to, what passwords you want to use. But the code you actually execute all inside the container.
It also helps with things like A/B testing and that sort of thing. So you want to be able to
Yes.
launch multiple versions and sort of try things out.
Yeah. So and that was why it was also kind of hard to say one hard and fast rule in terms of that. But Julian had a question, and maybe it'd be cool to hear everyone else's kind of thoughts on this. How do we populate or seed our databases? Do we do that after deployment? And I guess the question for me, Julian, would that be databases that are running in the containers, or just databases that the containers are talking to as they start? what scenario did you have in mind there?
More when you start up your containers, especially also for different deployments, because we have, for example, we are not allowed to see the actual data for some of those clients because it's privileged mental data. So there is actually sets of dummy data that each time we deploy, we need to populate that deployment with either dummy data or actually some of those are not actually, so some of my deployments I try not actually to run my database in a container. I would rather choose something from Amazon or G-Cloud or something.
Yeah.
Yeah, sorry, I totally
No problem.
lost.
So
No.
yeah, Julian, I mean, you could definitely use the cloud providers database. We've traditionally used, say for instance, for Azure SQL or something, and then have a minimal amount of data put on there just so that the application can start up and verify that it's running. But then the actual seeding of the data is managed either by a different process, or it's managed by a team of people that would have a tool that checks the
Would you
versioning.
start another pod, for example, and run an Ansible script inside there?
Yeah.
So
So yeah,
that's what I'm currently doing.
Yeah, so the term that we kind of typically use in that space, Andrie, you can correct me if I'm wrong, is an init container, which is basically a short-lived container that starts before the main container, and it exits when it completes, and then the container itself, the main container kicks off. So that's
part of the container life cycle, or the pod life
yeah,
cycle.
yeah.
Okay, sure. So I should just before the container. Okay, no, sorry, I'm starting to make sense. Thanks.
Yeah, so if you look up init containers, that might give you an idea. But I'm also, obviously, I'm not entirely sure of the kind of data and things like that, as you mentioned, the constraints that you're under in terms of how you get that data in.
Julian?
An Ansible loading stuff from an vault that an Ansible vault that you kind of unload into the database, all of those kind of things. It could be several ways.
Go and have a look YouTube. Search for Martin Founder. Search for Kafka and search for fraud systems. But he talks about how to use Kafka and the single source connectors to warm up in container database. So you would do something like Redis database. The big thing here to remember with containers is it doesn't help having 40 or 50 containers where the applications can scale out, but you still then get bogged down by a single database. So what you want to do is the container and the application need to scale together. So for every time you bring up an app, you definitely want to give it its own data or its own copy of the data. But now you're sitting with a situation is, as you scale the containers up running the app, you also need to keep the data in sync. This is where something like Kafka will actually come in. So if you bring Kafka, fraud systems, and Martin Fowler is the architect that speaks about it. Just do a YouTube, you'll find a couple of things there, and ways to architect microservices, containers, everything, and not how to run into. You got this awesome scalability horizontal on the app environment on the website, but then you're still bogged down using the old architecture on a single shared database. There's a couple of ways you can do it, but that's the easiest way, and it works. It's also how Netflix and LinkedIn and everyone has done it.
Because we have some weird big production Drupal websites, and that's actually one of the big problems. Is actually the big database.
The shared database. Yeah, the shared database. Yeah. I'm happy to also talk afterwards. If just get my information from the LSD guys.
I'll get it from Shaw.
Yeah, George and Julian, I think also in terms of things like Drupal and stuff like that, I suppose it would apply to WordPress and, in a lesser sense, because it's not quite as big a deal as Drupal in terms of size. But obviously Drupal a Drupal system can hold multiple sites within it. If you wanted to containerize effectively, you'd probably want to split out those sites rather than effectively centralizing them into one DB. You'd rather have more of them split smaller rather than fewer of them big. But
the thing is, we're actually moving those to a Laravel backend at the moment, and then writing a front end in Vue.js. But while those projects are in progress, I still need to maintain the old infrastructure. Because most of our clients usually come with the issue when they reach their scaling issues. And that's when they jump and they want Kubernetes and cloud and all these types of fancy deployments. And then we usually recommend that we rewrite those applications in something that's more container friendly, and that's usually a good fit for us. It's usually a Laravel backend with a Nuxt.js frontend.
I would then say definitely look at Kafka and do some exploring of Kafka. It's what's tying together the glue between, if you think about the old mainframe architectures, and we're really now going back to legacy. Where mainframes are costed by MIPS, and the more queries that mainframe database gets, the more expensive it gets. So what they've done in the world is they bring the microservices architecture into it, but they need to contain and offload the queries onto microservices while still running the old legacy mainframe, and actually bringing those two environments together from a data sharing point of view. That's where things like Kafka can come in and help you tremendously. And it also fits it perfectly with a microservices container architecture and stuff.
Thanks, George.
Questions?
I just find our database too big to do that sort of stuff. Maybe just because we've got a bunch of sharded servers, we're running around like half a terabyte of database. It's kind of hard to spin up in a container. So we keep most of our data and Redis queues and stuff like that on their own server.
Yeah.
They use all the resources they can get their hands on, and we just use the applications in containers.
Yeah, well said, Wayne. Yes, the issue of size there does make quite a difference. 10 terabytes.
That's
or
what she
3
said.
Yeah.
It's good to end the meetup on it. That's what she said, joke.
I do feel that we must rather be more inclusive, and that's what they said.
Yeah.
My bad.
Yeah, no, but if are there any other questions for Mac? Tim, I see Tim needs to go now. But if there's no other questions, I'd like to thank all of you for joining us tonight. It's not the circumstances that we wanted to meet under, but here we are. I think it went quite well.
I like it, actually.
Yeah, I think it went quite well. Which was kind of, the chat window was really handy tonight to see people answering questions and helping each other out with the info. That's something we normally don't have at the events, but maybe we can work out a nice physical digital event split in the future. And I hope the next time we meet, it's not under lockdown circumstances. I'd like to thank Tim and Elastic for putting the time in to do the APM demo. Mac and Andrie, thanks a lot for preparing a great demo and answering the questions. Thank you very much. And Steph for all the help with Zoom and all of that. And then lastly, I just want to thank everyone for joining us tonight. These community events drive around you. We're going to send out a survey soon to just kind of get an idea of what you thought about it and what you'd like to see in the future. And yeah, good luck during lockdown. See each other soon.
Cool.
Oh, cool, Charles. Thanks.
Thanks, everyone.
Thanks for joining.
User group feel.